This is the topic 2, 3 states of matter. The kinetic theory of matter states that matter is composed of a large number of small particles that are in random motion. These small particles is referring to the individual atom, or molecules. The atom and molecule will be detailed in the chapter 6 of Form 1. These particles are too small, and only can be seen under the electron microscope. Matter can exist in 3 different physical states. The first is the solid state of matter. The second is the liquid state of matter. The third is the gas state of matter. In this 3 physical states, these particles that constructed the matter are remaining the same. It means that the chemical properties of the matter in the 3 states is remaining the same. The properties of each state of matter, explained by the kinetic theory of matter. The kinetic theory of matter describes that a matter has a different arrangement and movement of particles in different physical states. The physical states are referring to solid, liquid, and gas state of matter. It makes each state of matter has different physical properties in its shape, volume, density, and compressibility. In the following part of the video, we will discuss how this 4 physical properties is influenced by the arrangement and movement of particles in their different physical states. We first see about the matter in solid state. In terms of arrangement of particles, the particles packed closely together, in a fixed position, and the spaces between particles are very small. Movement of particles. The particles have low kinetic energy, hence they can only vibrate about their fixed positions. These arrangement of particles, and their movement, make the matter in solid state have a fixed shape, a fixed volume, high density, and low compressibility. It means that it cannot be compressed. About the matter in liquid state. In terms of the arrangement of particles, the particles in liquid state are packed closely together, but not arranged in a fixed position, and the spaces between particles are moderate. About the movement of particles in liquid state, these particles have higher kinetic energy, and able to slide past each other. With the above mentioned, matter in liquid state got no fixed shape. It has fixed volume, moderate density, and has poor compressibility. It means it cannot be compressed. For the matter in gas state, in terms of the arrangement of particles, the particles spread far apart from each other. They not arranged in a fixed position, and spaces between particles are large. About the movement of particles, they have high kinetic energy. They move freely, and randomly in all direction. Collisions happen very frequent among the particles. With the arrangement, and the movement of particles in gas state, the matter in gas state has no fixed shape, have no fixed volume, have very low density, high compressibility, at which they can be compressed easily. Now let's talk about how the changes in the state of matter can happen. The changes in the state of matter, that caused by heat absorption, and heat of matter, can be explained based on the kinetic theory of matter. According to the kinetic theory of matter, when a matter in the solid state is heated, heat energy is absorbed by the particles. This causes particles to gain more kinetic energy and move faster. Hence, the temperature increase. As a result, the matter changes from solid to liquid. And, if it is heated furthermore, more energy will be absorbed, and eventually change to be gas. According to the kinetic theory of matter, when a matter in the gas state is cooled, heat energy is released by the particles. This causes particle loses more kinetic energy. They move slower, hence the temperature reduced. As a result, matter change from gas to liquid. And if cooled furthermore, more energy will be released, and eventually changes to solid. In general, that matter state can be categorized into two processes. The first is heat absorption process. The second is heat releasing process. This two kind of processes will be detailed further in the following part of video. We first talk about the heat absorption process. Melting, boiling, evaporation, and sublimation are the heat absorption process. That happens when the heat is absorbed by the particles from its surrounding. About the melting process. When a solid is heated, its particles absorb the heat. With heat energy, the particles vibrate faster, because heat energy is converted to kinetic energy. With heat energy, the particles vibrate faster, because heat energy is converted to kinetic energy. With heat energy, the particles vibrate faster, because heat energy is converted to energy. When the particles have enough kinetic energy to overcome the forces of attraction between them, they break away from their fixed positions, and move freely, and randomly. This is liquid. This happens at the melting point. This is about the boiling process. When a liquid is heated, its particles absorb the heat. With heat energy, the particles move faster. Because heat energy is converted to the kinetic energy, and collisions occur between particles become more frequent. The particles spread apart further, and moves rapidly in all direction. This is gas. This happens at the boiling point. This is about the evaporation. Different from the boiling process, evaporation happens only on the surface of the liquid. At any temperature below its boiling point, and this is a slow process. When the particles at the surface of liquid gain enough energy to escape as a gas particle. Evaporation process of a matter occurs at any temperature below its boiling point. Another heat-absorbed process is sublimation. Sublimation happens when solids are heated, at which particles at the surface of solid gain enough energy to escape as gas particles. In the sublimation process, solid changes directly to a gas without melting. Sublimation can easily happen on the solid, which have low melting and boiling point. For example, the solid carbon dioxide, dry ice, ammonium chloride, iodine crystal. You can see this from ice cube surface too. But the rate of sublimation of ice is lower, if compared to the dry ice. Now we learn about heat releasing process. Now we learn about heating process. Now we learn about heat releasing 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 process. Freezing, condensation, and desublimation are the heat releasing processes that happen when the heat is released from the particles to its surrounding. We first talk about the condensation process. When a gas is cooled, its particles release heat energy. The particles move slower because they lose their kinetic energy as heat. The particles move slower because they lose their kinetic energy as heat. The particles move slower because they lose their kinetic energy as heat. The particles move slower because they lose their kinetic energy. The particles move slower because they lose their kinetic energy as heat. The particles move slower because they lose their kinetic energy as heat. Forces of attraction between particles become greater than their kinetic force. Hence, they are being pulled closely to each other. When the particles is closer enough, the gas turns into liquid. This occurs at temperature lower than boiling point. About the freezing process. When a liquid is cooled, its particles release heat. When a liquid is cooled, its particles release heat. The particles move slower, because they lose kinetic energy as heat. Forces of attraction between particles pull the particles closer to each other. When particles no longer have enough energy to move freely, and will vibrate about their fixed position, this is solid. This occurs point about the desublimation process, and this is also called deposition. Desublimation process happens when gas releases energy and changes directly into solid, without going through the liquid stage. For example, snow is formed when the water vapor directly changed to be ice, without first becoming a liquid. There is a phenomena that temperature remain constant during melting, freezing, and boiling process of matter. Now, we will discuss this phenomena. When a matter is heated, its temperature increase, and when it is cooled, its temperature decrease. When a matter is heated to the melting point and boiling point, the temperature will remain constant, because heat energy is absorbed, and the heat energy is used to overcome the force of attraction between the particles. When a matter is cooled down to freezing point, the temperature will remain constant, because the force of attraction between the particles is formed. Mass remains constant during physical changes of matter is another phenomena. Now, let's discuss this phenomena. The physical changes of a matter between the solid, liquid, and gas. Of the change of the arrangement and movement of the particles in a matter, no quantity change of particle is involved. Since there is no quantity change of the particles, the mass of the matter remains constant during the physical changes. This phenomenon is called the conservation of mass. For the last, let's see the diffusion rate in the three states of matter. Diffusion of the matter is the process of movement of particles from higher concentration area to a lower concentration area. Diffusion can happen in all three states of matter, solid, liquid, and gas. This is because there are spaces in between the particles. The rate of diffusion of a matter is highest in its gas state, followed by in its liquid state, and lowest in its solid state. Diffusion of a matter in its gas state is fastest, because the gas state have higher kinetic energy and have the largest space if compared to the particles in liquid and solid state. The diffusion rate of a matter in the liquid state is lower if compared to the gas state. Diffusion in solids is the slowest because the particles in a solid can only vibrate at fixed position, rather than moving from place to another, and the spaces between the particles is smaller. This is an example of diffusion in gases. When a perfume is sprayed at a corner of a room, the smell of the perfume can be detected at a few meters away. This is because particle of perfume mix with air particle through the diffusion process. The perfume particles are diffusing from the area with higher concentration to the area with lower concentration. The follows are the diffusion rate comparison in gasifieds and solids. First of all, let's check up the diffusion in gas. The procedure is, a gas jar containing air is placed upside down on a gas jar of bromine vapor, which is a reddish-brown color gas. The observation is, after few minutes, the gas jar containing air also becomes completely reddish-brown. For the discussion of the phenomenon, the space between the bromine particles and space between air particles is very big, and they have high kinetic energy. This allows the diffusion rate of bromine gas in the air is fastest. Let's see how the diffusion occur in liquid. The procedure is, a small blue crystal of copper, 2-sulfate, CuSO4, is placed in a test tube filled with water. The observation result is, after a few hours, the transparent water turns blue. The observation result is, after a few hours, the transparent water turns blue. The observation result is, after a few hours, the transparent water turns blue. The observation result is, after a few hours, the transparent water turns blue. The observation result is, after a few hours, the transparent water turns blue. The discussion is, the rate of diffusion in liquid is slower than diffusion rate in gases, because space between the water particle liquid, is smaller. If compare with the space between the gas particle. Now, we see the matter particle diffusion in solid state. The procedure is, a small crystal of copper, 2-sulfate, CuSO4, is put on the top of gel-filled test tube. Test tube is closed with stopper, and place invertedly. The observation is, a day, the gel turns blue. After a few days, the gel turns blue. After a few days, the gel turns blue. After a few days, the gel turns blue. The discussion for the experiment is, the rate of diffusion is very slow in solid. This is because, the space between the gel particles, solid, is very small. If compare with space in gases, and liquids. This is all the content of topic, diffusion rate in the 3 states of matter. And we have just done the learning of Chapter 5, Matter. Thank you for watching, have a nice day.